Every second a star is born, and every second another dies, in an explosion so powerful it can outshine an entire galaxy. But how does a star live its life? From dusty beginnings to fiery end. You're watching Mindwarp Science. Subscribe for more mind-blowing facts about space, time, and everything in between. What is a star? It's a massive, glowing ball of gas held together by gravity. Stars shine by burning hydrogen in their core through nuclear fusion. This process creates energy, light, and heat, making stars visible in the night sky. Our Sun is an average star, not too big, not too small. It's just one of hundreds of billions of stars in our galaxy. Ever wondered where stars come from? Let's dive into the cosmic nursery, nebulae. These massive clouds of gas and dust are where stars are born. Gravity pulls particles together, forming denser regions. These regions collapse, creating a protostar. It's like a star embryo, still forming, not yet shining. Join us as we explore the birthplace of stars. Segment 3. Protostar to main sequence. As the protostar grows, its core gets hotter and denser. When the temperature hits about 10 million degrees Celsius, fusion begins. Boom! A star is born. Now it enters the longest phase of its life, the main sequence. This is where the star finds balance. Gravity pulling inward, fusion pushing outward. Our Sun has been in this phase for 4.6 billion years, and it's only halfway through.
Welcome to Segment 4, Stellar Mass, the Decider of Destiny. The mass of a star decides everything about its life. Small stars, like red dwarfs, live for trillions of years, quietly burning hydrogen. Medium stars, like our Sun, have a flashier life. Massive stars, they live fast and die young in violent explosions called supernovas. More mass equals a shorter life, but a more dramatic ending.
Welcome to Segment 5, the red giant phase. When a medium-sized star exhausts its hydrogen, it starts fusing helium. This fusion causes the star's outer layers to expand, transforming it into a red giant. Our Sun will enter this phase in about 5 billion years. It'll grow so large, it might engulf Mercury, Venus, and possibly even Earth.
Segment 6. Planetary nebula plus white dwarf. Eventually, helium runs out too. The star can't support its own weight anymore. It sheds its outer layers, forming a beautiful glowing shell, called a planetary nebula. What's left is a white dwarf, a hot, dense core about the size of Earth, but with the mass of the Sun. Over billions of years, it cools and fades into a black dwarf, though the universe isn't old enough for any to exist yet. Segment 7. Massive stars, the supergiants. Now let's talk about the big boys, massive stars. These stars burn through their fuel much faster. After hydrogen, they fuse helium, then carbon, oxygen, neon, all the way up to iron. But there's a problem. Fusing iron doesn't release energy. It costs energy. So when the core fills with iron, gravity wins. Segment 8. Supernova, the death explosion. The core collapses in just a fraction of a second. The outer layers crash inward, rebound off the core, and boom! A supernova. This explosion can be billions of times brighter than the Sun and visible from other galaxies. And here's the wildest part. Every heavy element in your body, like iron in your blood, was forged in a supernova. Segment 9. The aftermath. Neutron stars and black holes. After the supernova, two outcomes are possible. If the remaining core is small, it becomes a neutron star, incredibly dense and spinning rapidly. Some even shoot beams of energy like cosmic lighthouses. We call those pulsars. If the core is too massive, it collapses into a black hole, a region of space where gravity is so strong, not even light can escape. Welcome to the cosmic dance of star clusters and star factories. In the vastness of space, stars are born in groups, known as clusters. Some clusters drift apart, while others remain bound for billions of years. Our galaxy's spiral arms are bustling star factories, creating new stars. As some stars are born, others meet their end, continuing the cycle. This endless cycle of birth and death fuels the universe's evolution. Witness the beauty of the cosmos, where stars are both creators and creations. Segment 11. The bigger picture. We are stardust. You, me, the phone you're watching this on, all made of stardust. The carbon in your cells, the calcium in your bones, the oxygen you breathe, all born in the heart of stars. So the next time you look at the night sky, remember, you're not just looking at stars, you're looking at your origin story. Segment 12. Final thoughts and the future of star science. With telescopes like James Webb, we're seeing deeper into the past than ever before, witnessing the birth of stars billions of years ago. And we're only just beginning to understand how they live, evolve, and die.
The universe is alive with stars. Each one tells a story of creation, transformation, and explosive rebirth. If that blew your mind, just wait till you see what's next. Subscribe to Mindwarp Science for more cosmic journeys, and hit that like button if you've ever wondered what you're truly made of.